Dear colleagues, kindly rise as we welcome the platform party.
You may sit down. People standing at the back. It's a full house. I believe there's an overflow venue. Otherwise, you better have very strong legs. Molweni, good evening, colleagues, students, distinguished guests, and all the broader members of the university community. I am Professor Erwani Ramugondo, Deputy Vice Chancellor for People, Culture and Society. No surprises, right? Been reading those campus announcements, I see. It is my absolute pleasure to welcome you this evening to UCT's inaugural lecture by Professor Ryan Nefdt, who can't wait. Professor Nefdt is from the Faculty of Humanities. I'd like to extend a warm welcome to Professor Neft's family, friends, colleagues, collaborators, and students who have joined us this evening. This includes those who have joined us online. I also, and really more especially, extend a very special welcome to Professor Neft's wife, Anastasia, mom, Anthea, dad, Gordon. Is he right? I saw you earlier with perfect timing for the photo op. There's also a shout out for Uncle D.
Wow.
Academic work is sustained by communities of support, intellectual exchange, and encouragement. Behind every scholar worth their salt is a network of people who contribute to the long and often demanding journey of teaching, research, and public engagement. Your presence here reflects those shared commitments and relationships. An inaugural lecture marks an important milestone in the life of an academic. It offers an opportunity to recognize a scholar's contribution to research, teaching, and intellectual leadership. It is also a moment for the university community to engage with ideas that challenge us to think differently about the world and about the role of knowledge in society. This evening's lecture speaks to questions that increasingly shape how we understand communication, intelligence, technology, and human thought in a rapidly changing society. Before we get into the lecture, I must mention that ordinarily the Vice Chancellor would officiate over an event of this nature. And our Vice Chancellor, Professor Musa Mushavela, takes great pride in hosting inaugural lectures. He's ever currently away, so I'm stepping in for him. He should feel envious. I must also recognize those who have joined me as part of the platform party. Professor Ashosi Kesi, the Dean of Humanities, who will introduce Professor Nefdt, officially. We also have Professor Bernard Weiss, the head of Department of Philosophy. He has a blank check. Whether it's a vote of thanks or a response that he offers, that's up to him, as long as he leaves space for me to do closing remarks. This evening's lecture is titled Language, Patterns, and Automata, the Algorithms Behind Linguistic Reality. It invites us into a fascinating conversation about language, meaning, and the structures that shape human communication. Language is one of the defining features of human society. It connects people across cultures and generations, shapes identity, enables learning, and allows societies to organize, debate, and imagine. Yet language is also deeply complex. At a time when artificial intelligence and computational systems increasingly influence everyday life, questions about how language works have become more important than ever. How do humans recognize patterns in language? How is meaning created and interpreted? And what can formal systems and computational models teach us about communication, thought, and intelligence? These questions sit at the intersection of philosophy, linguistics, cognitive science, and technology. They remind us that the boundaries between disciplines are becoming increasingly porous. The most pressing intellectual and societal challenges of our time require collaboration across fields and new ways of thinking about long-standing questions. Universities have an important responsibility to create spaces where these conversations can take place openly, rigorously, and critically. At UCT, we value scholarship that combines intellectual depth with interdisciplinary engagement. We value research that not only advances specialized knowledge, but also contributes to public conversations about society, technology, and the future. To study language, therefore, is also to study the foundations of human understanding itself. An inaugural lecture is also a moment to acknowledge the importance of teaching and mentorship. Universities are shaped not only by research outputs and scholarly achievements, but also by the intellectual communities that academics help to build. The influence of a scholar is reflected in the students they teach. I'm sure there are many here tonight. Professor Nefdt. The young researchers they mentor, and the critical conversations they help sustain across disciplines and generations. This evening, we celebrate Professor Neft's contribution to the academic life of UCT and to the broader fields of philosophy, linguistics, and cognitive science. I now invite Professor Shosekesi to properly introduce the professor for the night.
I'll start by acknowledging our host, Professor Ryan Nefdt, DBC People, Culture and Society. And I'd like to acknowledge the presence of Professor Bernard Weiss, colleagues, family, and friends. It's with great pleasure that I get to give a few remarks about one of our superstar academics, Professor Ryan Nefdt. And it's been incredibly exciting to witness Professor Neft's trajectory from senior lecturer when he joined UCT a few years ago to professor in record time. bringing so much energy and excitement to the department and the faculty. Professor Ryan Nefdt's popularity with undergraduate students is electric. He's an excellent teacher, and in my time as dean, I have seen few teachers who animate student engagement as much. His own head of department testifies to his pass rates, his student evaluations, which are of excellent quality. And of course, as the winner of the Dean's Teaching Award a few years ago, I can also testify to his impressive skill as an innovative and extremely engaging teacher and mentor to his students, who absolutely delight in having him as the lecturer. Professor Ryan Nefdt has contributed significantly to leadership in the department, in the faculty, and the university by serving on multiple committees and a short stint as deputy dean. He has also organized numerous significant public conferences and has been a co-organizer to more in collaboration with international universities, affording our students and the broader university community an injection of quality in the general life of the university. The brilliance of Professor Nefdt is not only recognized at UCT, but the world over. And I want to take a few minutes to share in some detail the global value of his scholarship and to contextualize his value to UCT. Professor Nefdt's scholarship, as the DVC has already mentioned, focuses on the philosophy of language and the philosophy of science and linguistics primarily, and extends to cognitive neuroscience, artificial intelligence, and other human sciences. His work reflects on the nature of linguistics as a science, simultaneously engaging him in the philosophy of science, an incredibly powerful set that puts him into conversation and develops from the famed Noam Chomsky's work, which has been the bulwark in this field for 60 years. Professor Nefdt arrives and departs from Chomsky, ushering his field into a new promising trajectory that has many followers cheering. Indeed, Professor Nefdt's remarkable achievements is in the publication of his two books, Language, Science and Structure, and The Philosophy of Theoretical Linguistics. It is especially noteworthy that both books were published within 2 years by two leading academic presses in philosophy, the Oxford University Press and the Cambridge University Press. The first book contributes mostly to the philosophy of language, breaking from a traditional conceptual analysis towards a focus of linguistic practice as a behavioral science. The second book is praised for its remarkable breadth and authority as the most complete survey of modern philosophy of linguistics, already showing signs that it will be a required read for anyone approaching the field. The success of his work has been tracing the development of his own field, identifying its strengths and weaknesses in relation to its current praxis, which has massive relevance and urgency for our present and future. This has earned him respect by philosophers and linguists alike, receiving honors from premier associations in his field, nominations for prestigious book awards, and being a finalist for the Oppenheimer Award. He has been awarded a senior research fellowship in the UCT Bristol collaboration scheme, and his pioneering work on artificial intelligence from a philosophical perspective enriches the many considerations, positive and concerning, about the role of AI for our present and future. His recognition as an international leader in his field is well illustrated in the invitation for him to be the editor of the Oxford Handbook of the Philosophy of Linguistics. He is also one of the most prolific scholars in his field, and I won't mention numbers, so the rest of us don't have to feel bad. The excellence of his output is of the highest quality, as he is now firmly established in his international reputation, proven by regular and increasing citations and reviews, in addition to countless invitations to showcase his work. He visits the world's prestigious universities across Africa, Asia, Europe, and North America, as well as across the length and breadth of South Africa. Professor Nefdt is a member of the prestigious Holberg Prize Committee. In 2021, he was listed as JCI Top 10 Young Outstanding South Africans. The same year, he received the Vice Chancellor's 2030 Vision Fellowship and became an NRF Presidential Rated Researcher and won the HSRC Medal for Emerging Researcher. The previous year, he obtained the UCT College of Fellows Young Researcher Award and a UCT Grant Seekers Excellence Award, and the list continues. His work is original, creative, dynamic, rigorous, engaging, impressive, relevant, reverent, current, and futuristic. We are fortunate to have him in our ranks. So, esteemed guests, I have the pleasure to welcome to the stage a phenomenal force in the field of philosophy, Professor Ryan Mark Nefdt.
No pressure. Okay. Is it possible for me to remove? Just pull it up. Okay. Thank you so much. I got into academia to accompany my obsessive pacing habit. So not sure I'll be at the stadium for too long. At the stand for too long. Sorry, my soccer team won last night. Come on. So thank you all for being here. This is really an amazing, amazing turnout. I see friends, family, colleagues, so many people who have been part of this journey, my wife, my mom, my dad, Uncle D. Yeah, I'm saying all these things partly to like settle the nerves. I didn't think I'd have any, but they do manifest eventually. So instead of giving you a lecture on a particular idea or topic, I want to take you on a little bit of a journey of how I arrived at my way of thinking about language and society and artificial intelligence and these kinds of things. So I think the title can be imposing, and I want to demystify a lot of the terms. So if anybody feels that they don't quite follow, it's my fault, not yours. So I was thinking of a slogan for my work up to this date after however many years since my PhD and maybe during my PhD. And I think the best slogan I could come up with was the science of language and the language of science, and how these two ideas intersect with one another. And there are many different ways to approach this. I have colleagues from the philosophy of science, Jack Ritchie. I have linguistic colleagues, Raj Mestri in the audience. And of course, Bernard will give his rendition of why I'm wrong about everything. So there are many different ways to approach this. And the way I try to approach it is through understanding a few ideas that spawn from rather simple roots. So I know the talk is language, patterns, and automata, but I'm going to do that in reverse order. So I'm first going to talk about what an automaton is, what I mean by that, and why it's such a powerful idea. And then I'm going to talk about how you base a methodology off this powerful idea. And eventually, the last step, if everybody's still awake, is to look at how this relates to what a language is and how we study that language, because that's really the important bit of this. Language is so ubiquitous, and language is often considered something that makes human beings unique in the animal kingdom and has even established our dominance across. So I think it's an important topic. It's one of the most important topics to look at, but it's a complicated topic. It's got so many vicissitudes and so many components that I thought, instead of starting off or telling you what a language is, I do something a little bit simpler. I'd start with a simpler idea and then move on to that. So I'm going to tell you, what is life? To any biologists in the room, that was not a slight on your impressive discipline. But the idea behind one way of thinking about what life is will be what I take to be my inspiration for how to think about more complex topics like language, not that life isn't complex. So let's start like good philosophers do, and start with a thought experiment. Let's imagine that all of us are checkers on an immense checkers board. It's a 2D checkers board. We've all played the game before. And we initially start out with kind of a distributed location. There are a couple of checkers like this room, but let's say, imagine we're spread out a little bit more. And what if I told you that to understand life, you needed to understand only 3 basic rules? This is the famous mathematician John Conway's game of life that has inspired a lot of philosophy. Any live cell, any one of you in your checkers board with fewer than 2 live neighbors dies. Sorry. And we only look at our 8 closest neighbors when we evaluate this. Any live cell with more than 3 live neighbors also dies. Overpopulation. Sorry about that one as well. But here it gets interesting. Any dead cell with exactly 3 live neighbors becomes a live cell. So this is the mechanism that new life gets presented in. Now you might think, okay, we started with a checkers board. We started with 3 simple rules. What on earth could emerge from that? Surely just not much, right? But after a number of runs, a number of generations of just letting those rules play out on a randomized board, we start seeing immense complexity. There's even a cottage industry among mathematicians and hobbyists to actually find all the patterns that you can possibly see in the game of life. Some things have been labeled gliders, that's a glider gun. And people study all the patterns that just emerge naturally from those 3 simple rules. So there must be something going on here. We often approach questions like what is life with immediately asking the complex questions, but it seems like something very simple might account for even the diversity and the complexity of what we see in the world. Now, in a recent book, Blaise Aguirre Arcas, a Google researcher and part-time philosopher, speaks about abiogenesis. Now, that's a fancy-sounding word, but it's just basically, how does life start from non-life? Because at some point in the history of our planet, that needed to be the answer. At some point, life needed to emerge from non-living things, whether it was in the deepest recesses of the ocean, in thermal vents, or whatever the story is, this process needed to happen. And his answer is exactly like the game of life. Simple computations. The game of life is played constantly, whether it's in a bacteriophage, moving around by something called chemotaxis, which is basically just moving in accordance with the chemical composition of its environment. That's all that's happening. And if you look at that, it resembles a lot of what I showed you in the previous little clip of the game of life. More complex structures, and you get something like DNA. So life, there seems to be an underlying simplicity in a way behind the computations of life. Now you might think, okay, I came here to a philosophy talk, not to listen to a philosopher talk biology. And many of my colleagues in the room are social scientists, and they think, well, they could think, well, how does this get to the macro level? So in humanities, in the Faculty of Humanities, we're interested in things that happen to populations, things that happen to groups of people. So how do we get from this microscopic lens through which complexity emerges in simple mechanisms just bumping into each other to the macroscopic lens? And a clue here, and this is a clue that's supposed to open up my own research agenda, is a famous computational social science model by Thomas Schelling. So some people in philosophy of science would know this model quite well. I'm not going to go into the mathematical details of it, but I want you to just follow the the train of thought. So Schelling, the story goes, he walked one day into his cafeteria and he noticed all the biologists on one side and all the philosophers on one side and all the linguists on another side. And he thought, well, nobody told them they have to move in these directions and only occupy certain spaces, but they do it naturally. What's behind that? And the bigger question, which many of my colleagues in the room could answer with much more elegant complexity, is how does segregation in human populations work? So we live in a country that is still driven by the consequences of one of the most segregated and hostile racial environments that has been known in human history. How does that happen? Now, the answer is extremely complex, and there are many talks and books that you could read from many of my colleagues, and I would implore you to do that. But Schelling was asking the question through the lens of something like the game of life. And he said, okay, let's start with a grid. We're playing checkers again. And on this grid, you have two colors. Agents are either in the room, you're either red or you're blue. So he asked this question, what would it take to go from a completely random, diverse distribution of individuals to a segregated society? And this answer, computationally, was surprising. Literally, I can give you the actual number, 30% preference for somebody who looks like you. Now, I've known a few racists in my time. Most of them had a slightly lower tolerance for other people. They imagined that, you know, I want a society where I'm only with the people that look like me and everybody else should be away from us. But Schelling's model only says 30% of the time, you're happy if somebody looks like you. 70% of the time after that, you're completely fine. But once again, after a few runs, a few simulations, Schelling actually did it with checkers on a board physically. So he didn't initially do it with a computational model, but it was turned into a computational model shortly after. You get mass segregation every time. That's something fascinating to me because obviously, and this is a criticism of Schelling's model, obviously to explain something as complex as the apartheid system or any of the other events we see in the world today and in history, you need more than this. You need my colleagues in the Faculty of Humanities, and you need the social scientists to explain the complexities. But to get there without any of the extra, there's a pattern in this distribution that tells us something else is going on. We are beholden to certain kinds of mathematical constraints in the world that can have an effect on how the world looks in the end. So this isn't to say that all of the racial policies and documents and people's strong preferences don't end up creating a segregated society. Of course, that's part of the story. But even without those additional important layers, we can already see just computationally how to get to a completely segregated society from simple beginnings, from a simple grid where we're all playing checkers. Now, I bet before coming here, you didn't think that someone would explain to you how you go from checkers to apartheid. That is not the true origin story of that. But this inspired me, both the game of life and the expansion of the game of life, like thinking, inspired me to ask a question about language. But before we get there, we have to say a little bit about patterns. So here's a quizzically contradictory statement that I'm sure Bernard is thinking, well, that can't be true. Life doesn't start at the beginning. Obviously it does, but we don't start at the beginning of life. All of us were already born into complex societies. We're already born into racial identities and gender identities and political families that then either we opposed or we accepted, and that created our personalities going forward. So life doesn't start at the beginning. So science can't start at the beginning very often because we're already there. Scientists, as philosophers, as social scientists, we're already placed in the middle and we have to understand what's going on. We didn't get to be there when the game of life started. So we have to reverse engineer the rules. We have to look at the complexity, look at the noise, look at everything that we already see before us and reverse engineer, find out what those three simple rules were to begin with. They don't have to be three rules, but it's nice if you can get three. That's a nice number. But how do we do this? And here things get a little bit technical, but again, the technicality isn't the point. The idea behind the technicality, how we get from the complexity of life that we're already born into, whether literally born or born into as researchers and scientists, this is the methodology. The first part was sort of what in philosophy we might call the metaphysics, the way the world is. And now we're looking at how do we go from the way the world is to finding out what's going on in the world. And the answer is we find patterns. And I think at a high level of abstraction where we're not too specific, that's what we all do in life and then at the university and in science. We're just trying to find patterns, ways to operate, finding regularities in the world. Otherwise, everything is just chaos because the opposite of a pattern is randomness. So the second a pattern second randomness becomes something that we can reproduce. And I'll be a bit more specific about what I mean, because I'm going to borrow from a great cognitive scientist now who sadly passed away a few months ago, Daniel Dennett, who says, not only do we need to find patterns and we need to oppose the randomness, but what makes a pattern real? And here it gets technical, but again, I'm going to explain what he means here. If there is a description of the data that is more efficient than the bitmap, whether or not anyone can concoct it. And what on earth could he mean? This is the problem with philosophy. That's why people don't like us that much and invite us to their parties. We talk like this, but after a few drinks, then we make more sense. I'll get to the sober part now. Okay, so imagine this was a message I wanted to send to you. A bunch of numbers. If I had to send the whole message to you for you to be able to get the message, it's random. There's no pattern in it. If I can isolate and say, well, actually, I only want you to appreciate the even numbers, then there's a pattern that emerges that makes that entire bitmap, as he calls it, compressed. I've thrown out some information, told you what was needed for you to get the message. We do this every day with emoji speak. Language is a heavy tool sometimes, especially when we speak it the way that we do in academia. Imagine every time somebody texted you, they sent you an academic paper of their opinion about something. That wouldn't make sense. So we shorten things. We find ways to carry the message in a more efficient manner. And that's exactly what a real pattern is. And importantly, and I'll come back to this, Dennett thinks a real pattern is there even if we can't see it. So where do we go from there? To this idea of compression, making information smaller in some sense. And there are different ways to do that. How do we find patterns in the noise of life and science? Well, the first way we can do it is by what's called lossless compression. Here we find the regularities, the things that give us a path to understanding, but we try to keep as much information. So this is like if somebody sends you a picture, wants to send you a picture of something that they saw somewhere, but they send it in the heaviest file that they could possibly send. That's all the information. It's almost the depiction of reality taken out in all of its splendor. But it's a heavy file. You might say, come on, man, I don't have that much data. I can't take all of this picture, make it smaller, compress it somehow. And even apps like WhatsApp will compress the image for you because they don't want, they extract what the relevant part is so you can see what they're talking about, what the person wants to send, but without all of the other things. And I think that notion is called lossy compression. And I think that's at the core of what we do in science and what we do very often in humanities as well. We not only eliminate the redundant structure, the extra stuff, but we eliminate some things that we think are irrelevant. So when Boyle explained his famous ideal gas laws, he ignored certain kinds of collisions between gases. Nancy Cartwright wrote a very famous book, How the Laws of Physics Lie. And the point was, it's not like physics is lying to us, but physics tells us a story about the world that is more manageable and smaller than the real world. Because if I had to explain existence, physical reality to you, in all of the complexity of what physical reality is, then we wouldn't be able to start. It's just too much. So I have to find a pattern. I have to find some way to communicate it to you that leaves a lot of things out. And that's the essence of what a scientific model is, in my opinion. It's a lossy compression that brings you to a point where you can understand the underlying pattern. It leaves irrelevant information out. And you can fight over it, and maybe scientists very often do fight over that. So you've left something that actually was very important. In linguistics, in the philosophy of language, that's a big way of describing a lot of the disputes. Because people think when you describe language like this, you left out something important. You didn't have the right to do that. You compressed it too much, or you compressed it in the wrong way. But what's interesting about lossy compression, for any photographers in the audience, the more you make a file smaller, the more little quirks can start popping up, like blurry spots, even images. Many people in the paranormal community take these pictures when they find, oh, well, that's a ghost over there or something. But it's actually an artifact of a lossy compression. And I'm going to come back to why artifacts matter in a second. But Professor Kezi mentioned my first book, which came out in 2023 at Oxford University Press. And there my central idea was that the way linguists study language is via a scientific model that is basically a lossy compression of the real world, of what language is. It says language is complicated, but I'm going to give you a little model, and I'm going to show you how to understand it according to these kinds of patterns. So how does my work and this thinking contribute to the way these things have been conceived in society? It's a tricky one. According to my view, linguistics is a kind of structure. Maybe Bernard's going to pick up on this. I'm known as a structuralist. That's the position that I espouse in the literature. But basically, this question that philosophers and linguists have been asking about forever: what kind of science is linguistics? Is it a formal science? Is it like mathematics? Is it like biology? Is it sociology? My answer is it's a structural enterprise, which links it a little bit more to logic and mathematics and computer science than some other things, but with an important caveat. So now, that was the easy intro. Things are going to get rough. They should provide seatbelts on these chairs. I'm going to just give you a snapshot of why my view matters for a theoretical debate that is so strange that you might think, this is too strange to even follow. But I'm going to try to explain it to you, and then we'll see where we go. And then I'm going to, because I've been promised as an AI expert or somebody who at least has something to say about that, I feel obliged to say something about large language models like ChatGPT and things like that. But let's start with infinity. What do the following things have in common? A hall of infinitely reflected mirrors, the decimal expansion of pi, which is supposed to go on forever, with non-repeating as well, so it's a real number. The Fibonacci sequence, which is like, if you look at the leaves that you might sometimes see, the patterns of leaves that you might see in nature, you'll see this fractal pattern. It seems like it can envelop itself forever. And a grammar of a language. What do these things have in common? According to Noam Chomsky, whose work I have taken a lot of inspiration from, this is a weird quirk of natural language. It's not common to other biological systems. It contains an infinity. And by infinity, we mean a series or magnitude that just goes on forever. And why that's strange for a biological system to have is because everything in the biological world is not infinite. Every particle in the universe is a finite number. It's not infinite. It's a big number, but it's a finite number. And here, a linguist is saying, language is infinite. The structures of language allow you to constantly create new forms of language from the old ones, and it never stops, like the series of numbers that go on forever. And that was a controversial point. It was almost inescapable in the literature because it seemed like he was right. But at the same time, how do we accept that a physical system, a biological being, can create something like the decimal expansion of pi, which is not something we see in the real world, but language is something we see. And in my view, infinity is an artifact of a lossy compression of a model. So when you study language in a particular way, especially using formal methods, it looks like you have to assume language is infinite. But that doesn't mean the real world languages that we all speak and interact with really are infinite. It's a bit like that blurry picture that has a little watermark on it or something that's just a feature of the way we've contracted and compressed the information. That's what's going on there. That's at least one claim to novelty that I've had in my career to make this argument that Chomsky's right in a way, but he's right for the wrong reasons. Okay, so what about large language models? How does this feature into the picture? These are complex, they're based on complex neural network architectures, which I won't go into, but the things that's powering ChatGPT, when you ask ChatGPT every time, to give you a recipe and it drains a river somewhere in California for that recipe, it's based in part on this complex interconnection between information that passes through these weighted connections. They like weighted connections or parameters or ways that say how strong a particular connection is. Now, these can have billions of parameters. It's impossible for us to say. But something weird happened when we gave these networks the task. And this is the amazingness of large language models. We gave them the task. We didn't tell them, understand language. Tell us what we mean when we said, predict the next word for us. If anybody's ever played like that improv game, yes, and with your friends, and you're sitting around and everybody has to answer, you give them a strange scenario and they have to just go with it and say, yes, and. That's what a large language model is doing. It's doing improv all the time. So all the people who disparage the poor improv drama students should now take their words back, because this technology is powered by this inclination to just tell you, based on what it's seen, what the next likely word is in a sequence. And what's remarkable is that nobody expected that simple process to lead to a system that looks like it speaks and understands language for anybody who's ever interacted with chatbot. In fact, Stephen Piandadosi, a cognitive science in Berkeley, California, argued that the fact that these things work refutes everything Chomsky ever said. It refutes everything every linguist and philosopher thinks they know about language, because all we needed to do was give a lot of data, train a machine to say the next word in the sequence, and it sounds just like us. So maybe we're doing something like that too. Linguists have been a little slow to accept these things as genuine language users. They think they're parrots, they're mimics. There's some sort of magic trick happening that's pulling the wool over our eyes. They're not real language users in some ways. Again, the real pattern analysis offers a middle ground, because it says that actually large language models and humans are different, but we're all picking out the same kinds of patterns. And we have different architectures for doing that. I have a brain with all these modules and connective tissue. A large language model is powered by a server and running on this kind of statistical process, but it's picking out a similar kind of pattern in a space. There's a recent article in the famed behavioral and brain sciences, written by two famous cognitive scientists and computer scientists. And they make this claim. They say real patterns are the way to connect linguistics to large language models. And in one of those moments in life, as a philosopher especially, when you feel really validated, they say the idea came from me, which is kind of cool. It's nice to see when scientists are listening to us. Usually they don't invite us to their conferences. Okay, so now we've looked at what patterns are. And the last piece of the puzzle, the most important part, at least for my research agenda, is how languages fit into it. So what is a language here? I've been thinking about this for a little while. Actually, I've been thinking about it for quite a bit. And I can't say that I have a perfect answer, but I'll give you a flavor of the answer. But to understand my answer, you have to look at what previous answers looked like. So from the Chomskyan perspective, a language is a distinct part of the human mind or brain. It's literally in your Broca's area, maybe the pars triangularis, this little part of your brain, and it's different for different people exactly where your language is located. That's why often during brain surgery, it's important to have the patient be awake because you want to be able to plot where the important parts of their speech production is. Can't do that when they're sleeping because it moves with different people in different ways. But the problem with Chomsky's view is that linguists don't use fMRI studies generally. They do the kinds of maths that I was showing before. So it seems like a mismatch. They're saying it's in the brain, but they're not studying it with the tools of brain science. They're studying it with the tools of mathematics. And so this brought the New York Platonists around. And the Platonists said that language is like a mathematical object, like a triangle. It's like something out there in the world. Not in our world, but in another world, because our world isn't perfect enough to have an example of a perfect triangle or something with geometric figure. Platonists don't like my book very much. They say mean things, but their view captures some of the methodology of linguistics. And then there are the sociolinguists and the philosophers of language who say, well, we're missing the point entirely. Language is about people. Language is about how people interact and develop norms in a society, how they coordinate their behavior. That's how language emerged, through the need to communicate with one another. And so we've got people, we've got maths, and we've got the brain. And how do we put these different views together? Understanding that there's a convergence between patterns across the board. So language is a complex system, and this is one of those points where you might say, well, obviously it's a complex system, but it means in complexity science, there's something specific that's meant by a complex system. It's picking out the biologically real patterns. So something weird happens when birds and ants and economies get together. They are more than the sum of their parts. What that means is if you want to understand the complex behavior of an ant colony, they can build bridges, they can have triage centers. Looking at an individual ant isn't going to help you. You have to see the bigger picture. Something emerges. The murmurations of flocks of birds, they take over the sky, and it doesn't make sense why they don't all knock into each other. We can't even get through the N2 without any casualties. So it seems like something emerges when you put all these complex patterns together. And my answer, there's a sort of accepted list of complex systems, including things like economies and neuroscience and things. And one of my aims in my research agenda has been to put language on that complex system map. If it's still not super clear, the idea comes out a little bit in the difference between looking at something like an ant colony versus looking at a car engine. So with a car engine, you can identify many of the different parts. And knowing what each part does actually helps you understand what an engine is. It's complex, but it's not a complex system. With a complex system, something else happens. Just looking at the parts are not good enough to see what's emerging at the whole. And language is a bit like that too. And the problem in the previous accounts was that many people were looking at the parts that interested them specifically. But when you look at it through the real pattern analysis and you try to abstract away from these things, you start seeing that it's a complex system. There's a kind of emergence that happens. So the big picture takeaway from all of this is that languages emerge from these simple kinds of rules like the game of life. This structure literally rewired the human brain around 200,000 years ago. There's complex coordinations that we had to encounter when we were navigating, hunting and gathering and sheltering together. That rewired our brains to take on this complex structure individually. But these structures have also co-evolved with our cultures to produce further intricate patterns, so that the evolution never really stopped. So language itself is an emergent pattern from the interaction of all of these kinds of parts. Language literally emerges from the noise because of environmental and internal constraints that force it to do so. With that, I think I can say thank you very much. I hope that was entertaining or useful or interesting in some way. Thank you very much.
We now invite Professor Weiss to use his blank check.
Thank you, Ryan. I knew Ryan would be a hard act to follow, so we're going from high tech to no tech. So I do want to use my blank check to disagree with Ryan. That's partly because that's what we as philosophers do. When you value someone else's work, you try and disagree with it. But the main reason I want to disagree with Ryan is because, as I understand this evening's proceedings, he doesn't get a chance to respond. But seriously, it's a very proud moment for me to speak here at Ryan's inaugural address, because it doesn't seem so very long ago that Ryan was, let's say, an energetic presence in my undergraduate lectures, then an honours and master's student in the department. And in truth, it really isn't long since Ryan rejoined the department as a colleague and flew through the ranks with breathtaking speed, accumulating en route an impressive collection of accolades and honours. Needless to say, I'm tempted to take much of the credit for Ryan's success. Surely, those years of my instruction planted the seed of And indeed, Ryan likes teasingly to remind me that I taught him how to write philosophy. But the truth is that in the early days of his master's, he sent me a preliminary draft of his dissertation in which he tackled the difficult topic in the philosophy of time. This is the title of the dissertation, The Metaphysics of Time, Investigations into Tense Logic and B-Series Semantics. It wasn't a bestseller. The text was impenetrable and I reacted with irritation. For Ryan was then addicted to a flowery phrase or an impressive grammatical construction of which he had no shortage. I vented my irritation, pointing out that the aim of a piece of writing is to communicate both clearly and accurately. When he returned, Ryan presented a masterful piece of work. It was subtle in its argumentation and despite the difficulty, crystal clear. And it's true that he hasn't looked back from that moment, going on to get a distinction for the dissertation, then to write a PhD thesis in record time. We both have our PhDs, incidentally, from St. Andrews. And now to have launched an impressive research career, which sees the output coming in torrents and cascades. So this is where I'm going to move towards our disagreements. So Ryan and I share an academic interest in language. Ryan is a philosopher of linguistics, but I'm a philosopher of language. So what's the difference? Philosophy of language is the philosophical reflection on language. The philosophy of linguistics, as I understand it, is a philosophical reflection on the scientific study of language. Framed like that, they appear to be distinct, though related enterprises. However, conceding substance to this distinction, conceding that you can approach language in both ways, is to concede that philosophical, that is, armchair, a priori reflection on language, type of things that philosophers like to do. It's cheap, but it's merits need to be argued. Is to concede that we can address some of language's complexities in this armchair reflective way. So, for instance, we can illuminate how we, as finite beings, acquire potentially infinite ability to make and understand indefinitely many utterances, a problem Ryan mentioned earlier. Or we can illuminate the nature of linguistic meaning, how language represents the world, how linguistic meaning enables communication, what the relationship between thought and language is. I could go on, but this would obscure the simple point I'm trying to make, which is that pursued in the philosophical tradition, the assumption has always been that questions of that type are amenable to a priori philosophical reflection. Of course, that's not quite true about the tradition. Any generalization about philosophical traditions is always bound to be inaccurate in some way. So very often the philosophy of language is pursued because people want to clarify questions by focusing on language to clarify questions in other regions of philosophy. So that might be in epistemology, metaphysics, moral philosophy, or the philosophy of mind. So philosophy of language becomes a handmaiden to those disciplines. And sometimes too, philosophers raise skeptical problems about the apparent linguistic phenomena. So we have a tradition of philosophers questioning whether there is indeed linguistic meaning. But let that pass. For interestingly, in shifting his philosophical gaze from language to linguistics, Ryan takes a step away from that tradition. I don't think he altogether rejects it. He reads it and sometimes he draws lessons from it, but he deliberately moves away from it. The impulse for this move is, I think, Ryan's naturalism. Naturalism is a claim, to some effect, that science is the source of our understanding of phenomena. As such, this is a vague claim because it's at least unclear which disciplines count as science and why they do so. As it happens, Ryan is a moderate naturalist, and so relatively liberal in what he sees as legitimate scientific inquiry. But the details won't matter here. For the point I want to make is that for naturalists, peculiarly philosophical routes to understanding of phenomena lie beyond the acceptable boundary. So, as I've said, Ryan's focus is reflection on the scientific study of language. Two things, well, two broad things anyway, follow from this. The first is that Ryan's work lies within the philosophy of science, and so it's just as likely to take, perhaps more likely, to draw insight and inspiration from the wider subject of the philosophy of science, or from its cousins, the philosophy of physics, the philosophy of biology, or the philosophy of mathematics, than the philosophy of language. So sadly, Ryan and I have less and less to say to one another. So maybe part of this talk is trying to create a bridge where we can have more to say to one another. The second is that in trying to understand the discipline of linguistics better, its methods and results, Ryan needs to become clearer about the nature of language itself. Almost invariably, when philosophy turns its reflective gaze on another discipline, it needs to become clear about the subject matter of that discipline. Philosophers of mathematics, for instance, need to be clear about the nature of mathematical reality in order to understand how the practice of mathematics, the construction of proofs, for instance, leads to mathematical knowledge. You'll be glad to hear that I want now to start moving towards the conclusion of these remarks. You'll have plenty of time for your closing remarks. But in doing so, I want to dwell on the kinds of insights that emerge from Ryan's philosophical perspective, and then to hint at why I think there might still be room for my more traditional, perhaps old-fashioned a priori approach. So finally, I'll close with a modest pushback against some of the naturalistic thought. The Ryan's focus is on linguistic meaningfulness, not exclusively, but primarily. Mine on linguistic meaning. The contrast is, I hope, clear. A native speaker might tell you that a sentence of a foreign language is meaningful without telling you what it means. And what holds for the native speaker holds for linguistic theory too. The theory might tell you that a sentence is meaningful without telling you what it means. Technically, the contrast is between theories of grammar or syntax and theories of semantics. So a major concern for Ryan is to settle the ontology of language, what the syntactic elements of language are and what status they have. So I can't resist relating this anecdote that Ryan told me, although I'm sure I misremember its details. So Ryan told me that he once mentioned to someone that he'd been invited to give a presentation at Stellenbosch. Asked what he speak about, he said he'd be explaining what a word is. The response was, Ryan, you do understand that Stellenbosch is a university, not a primary school. So one of Ryan's major contributions is to read structuralist realist thinking in the philosophy of science into linguistics. Ryan's already mentioned that. The upshot is an interesting conception of language which is used as a structure instantiating real patterns in the world. Let me briefly illustrate, and here I'm going to move away from language. The structuralist about mathematical entities such as numbers thinks that to be a number is just to fall in a certain place in a certain series. So to be the number 4 is just to be the 5th item in a series beginning with an initial entity which counts as 0. Mathematical objects are just the same, are just places within in a linguistic structure. So an interesting thing I learned from Ryan is that linguistic theory provides a number of seemingly rival grammars, seemingly rival descriptions of the real pattern. So Ryan's response to the challenge is, I think, interesting. He needs to explain how it's possible to have these equally legitimate but seemingly different descriptions of the real pattern of language without being able to choose one as the right one. So his response is, I think, both plausible and attractive. He accepts the validity of the plurality of theories, and so is liberal about theorizing, But it doesn't pay for this by allowing either a fracturing in the phenomenon we're trying to describe or a diminution in its reality. The phenomenon is a real pattern. The alternative theories, different ways of describing it, each with distinctive theoretical virtues. The response, I think, is funded by thinking about the nature of scientific theorizing more generally, and so thinking which applies when the subject matter of the theorizing isn't ourselves. In a sense, the picture is one in which we see ourselves as observing ourselves. As linguists, we observe ourselves as speakers, and we do so in much the same way as we might observe any other natural phenomenon. Now, a somewhat analogous problem arises in theorizing about linguistic meaning. It's well known that, well, in certain circles, it's well known that if we treat a theory of meaning, in other words, a detailed specification of meanings in language, as a theory based on observation of linguistic behavior, and even idealize that evidence, too many theories will always pass muster. So here I want to protest that a liberal response like Ryan's is simply not an option. So Hilary Putnam, one of the primary instigators of this line of thought, explains how a scheme which states that cat refers to cherries and a scheme which states that cat refers to cats might each be idealized with the evidential base of linguistic behavior. I know it's a daft thing to think about, but the question is how we select the one scheme of meaning over the other. So Putnam complains that the first scheme, the one that says that cats refers to cherries, okay, when I say cats, I'm not talking about the animals, I'm talking about the word, complains that the first scheme is unacceptable because we know that cat refers to cats and not to cherries. So what does the predicament show? I think it shows that there's something important in Putnam's pointed use of the first person plural here. The philosophy of language draws on our own first personal experience of language as language users. It doesn't merely observe that use. Doing so is both necessary and sufficient to enable us to reject the alternative schemes of meaning. But doing so entails that the philosophy of language is not circumscribed by science. It aims at a species of self-knowledge, which is peculiarly philosophical. Thank you.
Sneaky suspicion that this conversation ain't over. That we will declare tonight the night of the teacher. We saw that, yes, a superstar is one who teaches in ways that you could just be here forever. Thank you. Thank you for this treat that was this lecture. And I pray that none of you end up like Chomsky. My job is done. I invite you now for refreshments outside. Thank you.
Get away from me. Station, you Let's go to the back. Forward. Right. So, don't wait for
Yes, and I said, okay, I'll check the
Yeah. That's your history. Oh, my. Yes. Okay, so you know, South Africa. Swipe the Lord. The Lord. Yeah.
The Lord don't see you there.
Right?
You must unmute him.
What if we went out that way?
Oh my goodness.
There is a door.
You must be a philosopher.
I am. Wow, kept me like needing to like really cut. This is what like that's
He loses me and then I get out. I think that's on. Thank you so much for the sound. I think that's good. And how are you? Well, thank you. I know. And you will start busy, but you just of course. I've got the people in your last. Now we have other plans. It's not a person. But I hope that you I can see black behind. My now. I told them from the beginning. Or you do. That was bad. Well, that was a big part of the interest. So, just to yes. Excellent.